The Number Devil, the Fourth Night. The places you dragged me to, a cave with no opening, a forest with ones for trees and mushrooms the size of armchairs. What about today? Where am I anyway? At the beach, can't you tell? Robert looked around. White sand, far and wide. The Number Devil perched on an overturned rowboat. The surf rolling in behind him, and not a soul in sight. I bet you've forgotten your calculator again, the Number Devil said. Look, how many times do I have to tell you? I can't take all my stuff to bed with me at night. Do you know that you're going to dream the night before you dream it? Of course not, the number Devil answered. Still, if you dream of me, you can just as easily dream of your calculator. But no, I've got to come up with one by magic. I've got to do everything for you. And then you complain and it's too soft or too green or too sticky. It was better than nothing. All right, I'll try, the Number Devil said. He raised his wand and a new calculator appeared before Robert's eyes. If the last one was like a frog, this one was like a soft, furry bed or sofa, and gigantic. At one end it had a little board with fur-covered keys, but the screen for the numbers stretched the entire length of the backrest. It was one weird calculator. Now enter 1 divided by 3, the Number Devil ordered, and see what you come up with. Robert punched the keys. The following answer came up on the green, on the long, long screen. 1 divided by 3.33333333. Doesn't it ever stop? Robert asked. Of course it does, the Number Devil answered. It stops where the screen stops. And then what? Then it goes on. You just can't see it. But it's always the same. 1 3 after the next. How boring. Right. And dumb, too. It's much easier to write 1/3. Then I don't have to worry about all those 3s creeping up. True, said the Number Devil, but then you've got to deal with fractions, and fractions, if I'm not mistaken, are something you can't abide. If 1/3 of 33 bakers can make 89 pretzels in 2.5 hours, then how many pretzels can 5 3/4 bakers make in 1.5 hours? No. Anything but that. Give me decimals anytime, even if the numbers never end. I'd just like to know what all those 3s are doing there. Simple. The first 3 after the dot means 3/10. The second one means 3/100. The third 3, 3,000, and so on. You can take it from there on your own. Get it? Good. Then try multiplying everything by 3. The 3, the 3/10, the 300, and so on. No problem, said Robert. I can do that in my head. Good. Now what happens if you add all the 9s together? Let's see. 0.9 plus 0.09 equals 0.99, and 0.99 plus 0.009 equals 0.999. 9's down the line. I bet it could keep on going like that forever. Right you are. Though if you think about it, there's something fishy going on. 1/3 plus 1/3 plus 1/3 equals 1. Doesn't it? Because a third multiplied by 3 equals a whole. Always has, always will. Well, what do you think? I don't know, said Robert. Something's still missing. 0.999 is nearly 1, but doesn't quite get there. That's the point. That's why you've got to keep 9s going and never stop. Easier said than done. Not for a Number Devil. With another little chuckle, he waved his walking stick, and in the twinkling of an eye, the sky was filled with an endless chain of purple 9s slithering higher and higher. Stop, Robert shouted. Please stop. It's making me sick. A snap of my fingers and they're gone, but not until you admit that the chain of 9s behind the 0, if it goes on forever, will turn out to be equal to 1. Meanwhile, the chain had kept growing and growing, and the sky slowly darkened with 9s. Robert was now as dizzy as he was nauseous, but he refused to give in. Not on your life, Robert shouted. No matter, not bad, said the Number Devil. Quite good, in fact. Can you prove that? I can. Show me. All you have to do is write a 0 and a dot, said Robert, and a 1 after the dot, 0.1. Then 2 after that, and so on. If I keep going, I'll put all the numbers that have just been written after the dot before I come to 0.2. Whole numbers, all. Of course, all whole numbers. Every number between 1 and bazillion can have a 0 and a dot before it, and every one of them is less than 1. Splendid, Robert. I'm proud of you. But as proud as he was, he could not leave well enough alone. He had a new idea. Many of your numbers after the dot have an interesting life of their own. Would you like to see what I mean? Oh, yes, said Robert, just as long as it won't cram the beach with famous numbers. Don't worry, your big calculator will take care of them. All you need to do is enter 7 divided by 11. Robert didn't need to be told twice. Hey, what's up? All those 63s, I bet it goes on forever. You bet right, but that's nothing. Try dividing 6 by 7. So Robert entered it. The same numbers keep coming back, he cried. 8, 5, 7, 1, 4, 2, over and over. It's like it's spinning in a circle. They really are fantastic creatures, numbers. In fact, there's no such thing as an ordinary number. Everyone has its own features, its own secrets. You never completely understand what makes them tick. That chain of 9s after the 0, for instance. All those 9s and still not quite 1. And there are many others that behave even worse and go off the deep end after their 0. They're called unreasonable numbers, and the reason they're called that is that they refuse to play by the rules. If you have another moment for me, I'll be glad to demonstrate. Robert knew by now that whenever the number devil made a point of being polite, he was in for something. But he was so curious he couldn't resist. Fine, he said. Please do. You recall our hopping game, I'm sure. What we did with the 2 and the 5 and the 10, 10 times 10 times 10 times 10 equals 1,000, which we write 10 to the third equals 1,000 because it's faster. Right. And when we hop with the 2, we get 2, 4, 8, 16, 32, and so on. As always with your little tricks, till the cows come home. Well then, said the number devil, how much is 2 to the 4th? 16. Pretty good, huh? Perfect, my boy. And now let's do the first hop in reverse, hopping backwards, so to speak. Only when you go backwards this way, you don't really hop. We call that step taking the rutabaga. If we are pulling one of those fine root vegetables out of the ground, so what is a rutabaga of 4? 2. Right. Taking the rutabaga is in the reverse of the first hop. So the rutabaga is of 100 is 10, and the rutabaga of 10,000 is 100. What's the rutabaga of 25? 25, said Robert, is 5 times 5, which makes its rutabaga 5. Keep it up, Robert, and you'll be my apprentice someday. Rutabaga of 36. The rutabaga of 36 is 6. Rutabaga of 5,929. Are you crazy or something? Robert shouted. How do you expect me to do that one? Mr. Bockel plagues us with enough dumb problems in school. I don't need to dream about them. Calm down, said the number devil. Little problems like that are what the pocket calculator was made for. Pocket calculator! The thing's as big as a couch. Be that as it may, you'll notice it has a key with this symbol on it. Which means rutabaga. Right. Now give it a try. The square root of 5,929 equals... Robert did as he was told and immediately read the following off the backrest of the couch calculator. 77. Fine. But now hold on to your hat and try the rutabaga of 2. Again, Robert did as he was told and got the following. Drat, he cried. It's utter gibberish. Number stew. I can't make heads or tail of it. Nor can anyone else, my dear boy. That's the point. The rutabaga of 2 is an unreasonable number. Is there any way of knowing how it goes on? Because I have a feeling it does. Right you are, but I'm afraid I can't help you. Taking the number any farther would mean running myself or a calculator into the ground. Wild, Robert said. A real monster. But write it like this. And butter wouldn't melt in its mouth. Well, let's try something a little less daunting. He drew a few figures in the sand and said, have a look at these. Count up the small boxes inside the squares and tell me whether you notice anything special about them. 1 times 1 equals 1 squared equals 1. 2 times 2 equals 2 squared equals 4. 3 times 3 equals 3 squared equals 9. 4 times 4 equals 4 squared equals 14. You bet I do. They're all hopping numbers. Right, you see how it works? Count the number of boxes on each side of the square and you've got the number to hop with. And vice versa. If you know how many boxes the square has, 36 say, and take the numbers rutabaga, you get the number of boxes along the side. The square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, or the rutabaga. Great, said Robert. But what's that got to do with unreasonable numbers? Well, squares are wildly beasts. Never trust a square. They may look innocent, but they can be full of tricks. Take this one, for instance. And he carved a perfectly ordinary empty square into the sand. Then he pulled a red ruler out of his pocket and laid it diagonally across it. Now, if each side has one length, one what? 1 inch or 1 foot, Robert interrupted. It makes no difference, said the number devil impatiently. One, whatever you please. Call it quing or quang for all I care. Now tell me how long the red line is. How should I know? The rutabaga of 2, shouted the number devil triumphantly. How did you get that? Asked Robert, who was starting to feel a little overwhelmed again. Don't worry, said the number devil. We're coming to it. All we have to do is place another square on top of the angle. He pulled out 5 more rulers out of his pocket and laid them in the sand, which made the figure look like this. Now guess how big the red square is, the one at the angle to the black one. I have no idea. The red square is exactly twice as big as the black one. Shift the lower half of the black one into one of the 4 corners of the red one, and you'll see why. So this part went there. It reminds me of a game I used to play when I was little, Robert said. Heaven and hell, we called it. We'd fold a piece of paper into sections, painted black and red. Open it to black and you went to heaven. Open it to red and you went to hell. And do you see that in this instance there's twice as much red as there is black? I do. Good. Now since the area of the black square is 1 times 1 quang, we agreed to call the length of each side a quang, remember? We can write it 1 squared. And if the red square is twice as large as a black one, what's its area? 2 times 1 squared, said Robert. In other words, 2. Correct. Then how long is each side of the red square? I'll give you a hint. It takes a backwards hop. I see, said Robert, the scales falling from his eyes. Rutabaga. You need to take the rutabaga of 2. Which brings us back to our cockeyed total unreasonable number of 1.414213 ... Stop, Robert said quickly. You'll drive me crazy if you keep on with that number. It's not as bad as that, said the number devil, but we don't need to work it out. Just don't go thinking that unreasonable numbers are a rarity. Quite the contrary. Take it from me. They're like sand on the beach, more common even than the other kind. But there's an infinite quantity of the other kind, the ordinary ones. At least that's what you've been saying and saying and saying. Because it's true, believe me. It's just that there are so many more unreasonable ones. More than what? More than an infinite quantity? Exactly. Now you've gone too far, said Robert in uncertain terms. I refuse to believe it. More than infinite? Nothing is more than infinite. That's a lot of malarkey. That's what that is. Want me to prove it? Asked the number devil. Want me to conjure up all the unreasonable numbers at once? No. Anything but that. The 9 chain was bad enough. Besides, what kind of proof is magic? Blast, the number devil said. You've got me there. But he didn't seem terribly annoyed. He merely frowned and started thinking hard. I could probably come up with another proof, he said at last, but only if you insist. No thank you, said Robert. I've had enough for today. I'm beat. If I don't get a good night's sleep, I'll be in for it tomorrow at school. I think I'll stretch it on your calculator if you don't mind. It looks awfully inviting. Be my guest, said the number devil, as Robert lay down on the fleecy, furry couchside calculator. You're asleep as it is. You learn best when you sleep. And he tiptoed off, not to wake him. Maybe he's not too bad after all, Robert thought. In fact, he's pretty cool. Robert slept peacefully and dreamlessly late into the morning. He'd completely forgotten the next day was Saturday, and on Saturday, of course, there is no school.